All right, good afternoon, ladies and gentlemen.
Is that cherry?
Today we are solving exponential equations.
I'm sorry.
So, using the one-to-one property, which we've done a lot of, and also by taking a log of each side. So first, I want to review what the one-to-one property is. The one-to-one property says if they have the same base, then their powers must be equal as well. And so we have an example, 32 to the 3x equals 8. And so we can rewrite that because I can trade out some stuff so they have similar bases. What base should we use?
2.
So we could rewrite 32 as 2 to the 5th. And we can rewrite 8 as 2 cubed, which would give us 15 x's. So now since the bases match, we can say that 15x equals 3. So x equals 3 over 15, which reduces to 1/5. Okay, so we know how to do that. What I'm going to do for solving by taking a log of each side, there is an infinite number of ways to solve these equations. And that is because of basically change of base. So what I'm going to do today is the first example, the first problem we do, I'm going to show you how to solve 2 different ways. And then hopefully you can see what I mean by it could be any base we want. But I am just going to solve all the rest of them using one way. Okay. But in order to do that, you have to know change of base. So change of base. So there is a formula that we can use to change any base of a log. So if we see the equation like log base 5 of 12. So this is 5 to what power gives us 12? Well, I don't know, but it's not much. It's like 1.2. I don't know. Okay. But our calculators can do this. So some of our calculators have log base in there already. But if you don't, we can use the change of base formula. And the change of base formula is log tall over log small. Log tall over log small, which means log of 12 over log 5. 5 being the small thing, the subscript, okay? Log tall over log small. And so if you plug that into your calculator, you'll notice this is log base 10 right now. And that's what our calculators have. So all of your calculators have log base 10. So you can see log 12 divided by log 5 turns out to be 1.5439. Well, it turns out that change of base really could be any base we want. So I could even say, hey, not only is it log 12 over log 5, but I could say it's log base E of 12 over log base E of 5. And what's really interesting about that is, well, what's log base E? Natural log. Okay, so we have a button on our calculator for that. So really, it would be natural log of 12 over natural log of 5. So natural log of 12 divided by natural log of 5 also is the same thing, 1.5439, which is kind of interesting. Well, it is also true that I could write log base 27 of 12 over log base 27 of 5. And it turns out that that still would give me the same answer. And the reason is because if I change the base, well, look, I could use change of base again on just the numerator and rewrite it as log 12 over log 27. I could use change of base on the denominator and rewrite it as log 5 over log 27. Now that's a complex fraction. How do you deal with a complex fraction? Keep, change, flip. So if I were to flip these, it turns out that those log base 27s would just cancel out, and I'm back to log 12 over log 5. So it turns out that change of base is kind of crazy. It doesn't matter what the base is. As long as they match, I can use whatever base I want. And that's where solving equations comes in. We can actually solve all of these exponential equations using any base we want. What I'm going to do is use the base that's most convenient for me, which is either a log base 10 or a natural log. That's because those buttons are available quickly on my calculator. Okay. So change of base. Most of you have log base in your calculators. You can change your base in your calculator, which is kind of nice. But if you have an older calculator, you can't do that. So I'll show you how that applies here. Example 1, solve the exponential equation, round to the nearest 10,000. The reason we're rounding is because, like I said, there are an infinite number of ways to solve these equations. All the answers will look infinitely different and mean all the same thing, which is why we round to the nearest 10,000, just so all of our answers can be in decimal form instead of some crazy base answer. So we have 3 to the 2x equals 80. As I said, I'm going to show you 2 different ways to solve this one. And then I'm just going to do the second. So whether or not you write down the first way is up to you, but I would just say watch for now. So 3 to the 2x equals 80. This is an exponential function because the x is in the exponent. I cannot solve an equation when the x is up high. And so I have to do something to drop it down. Well, we're allowed to drop powers if we have a log in front. So what we're going to do then is we're going to take a log. I'm going to take log base 3 of both sides of this equation. And because now I have a log with a power, that power is going to drop down. So I get 2x times log base 3 of 3 equals log base 3 of 80. Well, what's log base 3 of 3? 1. Why?
Because any number to the first power equals itself.
Because any number to the first power equals itself. Because if you give it a swirly, that makes perfect sense, right? All right, so this turns out to really just be 1. And so I have 2x equals log base 3 of 80. And how do you get x by itself? Divide by 2. And I'm going to go ahead and actually, can I multiply by half? Is that the same thing? Okay, I'm going to multiply by half. So I get x equals 1/2 times log base 3 of 80. Well, that's a great answer, but it's kind of meaningless for me because it's base 3. And so if I wanted to convert that to a decimal, then I would have to do 1/2, and I'd have to use change of base here. What would change of base be? Log 80 over log 3. And I can do that in my calculator. So log 80. Oh, I guess I'm going to divide by, there we go, 2 log 3. Divided by 2 log 3. Because there's a 2 there, times 2. Okay. 1.9943. So I get x equals 1.9943. That is 10,000s, right? Tenths, hundredths, thousandths, 10,000s. Okay. So x is approximately 1.9943. Well, that's great. A lot of steps there. But that involved this whole change of base thing. Now, I could have divided by 2. Like right here, I could have divided by 2. And the reason I didn't do that and multiply by half instead is just because I had to do change of base, and if I had to divide by 2 there, it would have been more confusing. Okay. All right. So that's one way to do it. Now, you'll notice we got to this point where I had log base 3 of 80. I strategically chose log base 3. Why did I strategically choose log base 3? Because log base 3 of 3 would cancel itself out, which was kind of nice, so it's handy. But I could have used any log. I could have taken log base 4 of both sides. I could have taken log base 12 of both sides. Because I still would have had to do change of base. Anyway, okay? So you can take a log of any base you want. It just might end up being more work at the end. Here's how we're going to do it. So the idea is the same. I can't solve when I have my power way up high. So we're going to take a log of each side. It's going to allow me to drop down the power. Well, I'm lazy. And because I'm lazy, I'm going to use a natural log. I'm going to take a natural log of both sides. Why? I could have taken a log base 10 of both sides because I have a log base 10 button. But natural log only has 2 characters to write, and the log has 3. So that's just me being lazy. All right, so I have 2x times the natural log of 3 equals the natural log of 80. Now, this is 2 times x times the natural log of 3. How do you get x by itself? Divide by 2 and the natural log of 3. 2 and the natural log of 3. 2 on top and bottom, natural log of 3, top and bottom cancels out. I'm left with x equals the natural log of 80 over 2 times the natural log of 3. And doesn't that look very similar to this? Okay? You see that? Same thing, except that this is easier. Okay? We're going to take a natural log every single time. Ladies and gentlemen, the hard part about this is putting it in your calculator correctly. So please be careful. We need parentheses around that entire denominator. But the natural log of 80 divided by 2 natural log of 3, you can see we get the same 1.9943 with a lot less work, right? 1.9943. So this is how I'm going to do things. I'm just going to take a natural log all the time. Okay? All right, letter B. What property are we going to use to solve that? One-to-one property. Because they have the same base, we know that 2x is equal to x squared minus 8. And then how do you solve that? Subtract the 2x. Sure, move that over. So we get 0 equals x squared minus 2x minus 8. And then what? Double bubble, yeah. All right, so x times x is x squared. What times what is negative 8? Minus 4 and positive 2. Very good. So we get x equals 4 and x equals negative 2. Do they both work? It's always a good idea to check. They do both work.
No.
They both work. They do. Mm-hmm. Are you thinking the negative 2 doesn't work? So e to the 2 times negative 2 should equal e to the negative 2 squared minus 8. This is e to the negative 4. Negative 2 quantity squared is 4 minus 8, which is negative 4. So it does work. The nice thing about exponential equations is that they don't have the domain restriction that a log equation does. Log equations have that vertical asymptote, which basically eliminates half the answers for x, okay? But exponential equations, if you'll remember, that's the Superman graph. Their domain is negative to positive infinity. That means that x could be anything. So that's pretty much going to work all the time. All right, okay, let's check a couple more. 7 to the negative 9x plus 2. That's what that says, negative 9x plus 2 up there. less 8 equals 34. I made a slight adjustment after first period today. Okay. Negative 9x plus 2. When we're solving exponential equations, you must isolate the base with your exponent. Whatever your base is, that's the 7 in this case, with our little exponent, it needs to be by itself first. So what should we do? Move the 8. So we have 7 to the negative 9x plus 2 equals 26. Now that my base is isolated, what allows me to drop my power? A natural log, taking a natural log of both sides. So when I take that natural log, my power drops down. Well, that entire power is negative 9x plus 2 being multiplied by natural log of 7. What is natural log of 7?
It's greater than
Almost 2.
Like 20.
So remember, natural log really is log base e, right? So this is log base e of 7. So e to what power gives you 7?
7.
No. It's 1 point something. 1.8 something crazy. But what my point is this is a number. It's some crazy number. 1 point whatever it was. Okay, some crazy number. If we had a number outside of parentheses, what would we do with it normally? Distribute it. Okay. So that's an option. You could distribute it. What else could you do? You can divide it away. So we're going to divide by the natural log of 7. Which leaves negative 9x plus 2. And this craziness I can do in my calculator. Natural log of 26 divided by the natural log of 7 is some crazy number, 1.6743. All right. Now, how do you solve for x?
Oh, you
Subtract 2. So what I'm going to do is just keep this running in my calculator. I'm just going to type in -2, and I get some crazy decimal. Negative 9x equals negative 0.3257. And then do what? Divide by negative 9. So again, you can just keep the total running in your calculator. So I get x equals 0.0362 approximately. Okay, so that last step we just divided by the negative 9. So be very, very careful. This is a big step here. Do the LNs cancel out? No, they do not. Okay, it's a whole operation. Remember, there's a whole swirly going on in there. No. 8 or 3, where? Right here? 0362. Yeah, 0362. All right, letter D. What should we do first?
Isolate.
Subtract the 1. All right, so negative 5 e to the 2.2x minus 7 equals negative 60. Then what should we do? Divide by 5. Very good. Ladies and gentlemen, our base is e. This is negative 5 times e. We must get rid of that first. So divide that number in front away so that our base is all by itself. Divide by negative 5 so we get 12. All right, what should I do now? Natural log, not ln natural. All right, so that gives me 2.2x minus 7, the entire exponent, times the natural log of e equals the natural log of 12. What is the natural log of e? 1. That's kind of nice. Okay, so natural log of e is the same as 1. Remember, it's e to the first equals e. And so I'm just left with 2.2x minus 7 equals the natural log of 12. And then what should we do? Add 7. So I have 2.2x equals the natural log of 12 plus 7. Is that the natural log of 19? No. Remember, natural log of 12 is some crazy decimal. E to what gives me 12? I don't know. It's, I don't know. 2 point something. It's a crazy decimal, okay? So don't think you can add those numbers together. And then what do we need to do? Divide by 2.2. And this is something I can just do all in one swoop in my calculator right here. I'm just going to make sure that I put the numerator in parentheses. Natural log of 12 plus the 7. Oh, never mind. I'm just going to do that first because I did it too fast. And then divide by the 2.2. So I'm getting 4.3113 approximately. Okay, ladies and gentlemen, today's worksheet is exceptionally tricky. I encourage you to spend, especially, the first like 10 are super easy, but 11 is where it gets tricky. So please send a delegate from your group to be like, go check the answers, okay? And check as you go. You will need to finish this worksheet.